Okay, so you're going to have several videos to catch up on for next week. I'll post the ones that we would have done over the past week and then check again on Tuesday because there'll be a new updated one. And then on Thursday when you come in, we can go over everything and then move forward. And I apologize for posting so many videos. It's just because you missed the first 2 weeks of class, so we have to catch up so that we make sure we can get through everything by the end of the course. So we're going to start with SI measurement, which is the standard international units. SI stands for Système International de Unité, which is just French for the United, sorry, I'm just going to see if I can zoom this in for you a little bit. It's just a French committee that has designated these units to be standardized around the world. Okay, so most countries use this. The obvious example that doesn't use it would be America. Okay, and so we use the meter as the basic unit of length, and each unit is a multiple of 10. Okay, so there's 10 centimeters in a meter, and 1,000 meters in a kilometer, and of course 1,000 is a multiple of 10, right? 10 times 10 times 10 is 1,000. So common SI units that we will use, things like a kilometer, and the abbreviation for that is km. If we compare that to a meter, like I just said, 1 kilometer equals 1,000 meters. And the conversion factor, this is the same thing. So 1 kilometer per 1,000 meters. Or we can also flip it around. So there's also 1,000 meters per every kilometer. Okay, so those are the same thing, just different ways to say it. Then we have something called a hectometer, and that's HM. And this isn't a very common one, but it's in there, so we have to know it. 1 hectometer equals 100 meters. So our conversion factor is 1 hectometer over 100 meters, or 100 meters per hectometer. Okay. And if we start at the meter, again, this is our standard unit, these guys will all get bigger, and then they get smaller going down. Okay, then you have a decameter. A decameter is DAM, and every decameter is 10 meters. Okay, and deca means 10. Okay, and this is why we have a decade is 10 years. A decathlon is an event with 10 events. So a decameter is 10 meters. And same thing, 1 dam over 10 meters, or 10 meters per 1 decameter. Okay, and then we have meters. And this is standardized, so 1 meter is 1 meter. So we don't need to convert that at all. Going down, we have a decimeter. So a decimeter is just dm. Okay, be careful not to get these two mixed up. Decameter is with an A, and decimeter is just dm. And there's 10 decimeters per every meter. Remember, a decimeter would be smaller because we're over on this side, so that makes sense. And then we have 1 meter per 10 decimeters, and 10 decimeters per 1 meter. Then we have centimeters, and hopefully that one sounds familiar because we do use this one in everyday life. So 100 centimeters in every meter. And this isn't a meter stick, there's 100 centimeters. 1 meter over 100 centimeters, or 100 centimeters per meter. And then lastly, we have a millimeter, which is the smallest one. And there are picometers and nanometers and all of that, but you don't need to know about that at this point. So 1,000 meters, or 1,000 millimeters, oh, Make sure I get two M's in there. Millimeters per meter. Okay, so again, 1 meter will be over 1,000 millimeters. And there's 1,000 millimeters in 1 meter. And just 1 second. Okay, so the big reason why we look at SI units is so that we know how to convert things. Okay, so the first unit, or the first method, is by unit analysis. So unit analysis. We can convert from one SI unit to another using conversion factors. And a conversion factor is just a ratio, and then we cross. Okay, and being able to do a conversion factor is a really, really, really helpful skill. You're going to use it in all your math and all your science courses too. Okay, the easiest way to do a conversion factor is to have the equation set up like this. Want equals have times no. And the no part would be your conversion factor. Okay, and that, by that conversion factor, we mean like this here. So these conversion factors, these are known. Okay, everywhere in the world, there's 1,000 meters in a kilometer. There's 10 meters in a decameter. Everywhere, ever. You go to Japan or Russia, South Africa, it's all going to be the same. So that's a no, because we know that to be true. So let's convert 3 meters into kilometers. So we want kilometers. Okay. And we have 3.0 meters. And then we're going to multiply that by no. And we know, let's look for a conversion factor with kilometers and meters. Okay, so we'll go up. Here we have kilometers. So it's either going to be 1 kilometer per 1,000 meters or 1,000 meters per kilometer. And if we go down, we always want to cancel things out. So we want to cancel out the m. So we'll put the m on the bottom. So 1,000 meters. And we want kilometers, so we'll put that on top. Meters cancel out. Okay, if you have a top and a bottom, they'll cancel out. And so your kilometers will equal 3 divided by 1,000, 0.003 kilometers. Okay, so 3 meters is 0.003 kilometers. Okay, let's try 7.3 kilometers into millimeters. Now, we want millimeters. And always think about it. Kilometers are really big, millimeters are really small. So there should be a lot of millimeters in a kilometer. Okay, so if we get a big number, then we'll know we're doing all right. So want equals have times no. Okay, and once you get conversion factor, you don't have to keep writing out this first want equals have to no, but we're just going to practice with it in case it's something you're not familiar with. So we have 7.3 kilometers. And we know, so from going from kilometers to millimeters, that can be difficult because it's not just automatically in here. But what we could do is go from kilometers to meters and then meters to millimeters. Okay, so let's do that because it's 2 steps, but it's going to get us the exact same answer. So we want kilometers on the bottom to cancel out. How many meters are there in 1 kilometer? I hope you said 1,000. Okay, so kilometers are canceled. But now we have meters and we want millimeters. So we got to do one more conversion factor. So we put meters on the bottom. So 1 meter. And how many millimeters are in 1 meter? If you flip back, you'll see that there are 1,000 millimeters. Okay, so our meters cancel out. I look at what I have left. I have millimeters and I wanted millimeters, so that's good. And then I just go 7.3 times 1,000 times 1,000. I'll get a very big number, 7,300,000 millimeters. Remember when we talked about it, since kilometers are very big and millimeters are very small, we thought we'd get a lot of millimeters, and we have. Okay, then there's another method. So that's the unit analysis or conversion factor. And then we can also do proportional reasoning. So we can convert between standard units by setting up two proportional ratios and letting x represent the number we're looking for. Okay, so if we want to convert 5.1 millimeters to meters, we will let x represent the number of meters. Okay, so we'll have 1 meter, and if we go from millimeters to meters, that's 1,000 millimeters. And that will equal x number of meters over 5.1 millimeters. Okay, so this part is what we know, right? That's a conversion factor, we know that. And this is what we want and what we have. Okay, and the way we have set it up, we can now cross multiply. Okay, so we end up with 1 meter times 5.1 millimeters equals x meters times 1,000 millimeters. And then this is algebra. So we want to get x meters all by itself. Okay, and it's being multiplied by 1,000 millimeters. The opposite of multiplication is division, and so we're going to do 1,000 millimeters. And then we have to do the same to both sides. Okay, so this will cancel out, and this will cancel. We'll have, and then this will be in meters. And over here, you'll see our millimeters cancel out. So we have 1 times 5.1 divided by 1,000, and we end up with 0.0051. Because our millimeters canceled out, the only unit we have left is meters. So x equals 0.0051 meters. And if you look, we wanted to get to meters, and that's what we've gotten to. Okay, so you can decide whichever method works better for you, proportional reasoning with the cross multiplication or conversion factor. Now usually conversion factor people find a little bit simpler, but either one is fine. Just find the method that works best for you. So when we're measuring, we can use personal reference. Okay, and it's reference spelled like that. And that's for estimating, okay? So these are things that we know in everyday life, and we can use them to apply to measuring. So the thickness of a dime is about 1, and that should be 1 millimeter, okay? The height of a doorknob is about 1 meter. And then 12 city blocks, so if you walk 12 blocks, it would be about 1 kilometer. And that's just estimating. But we can also use measuring instruments to be more accurate. And in math, we normally like being more accurate. And so let's think of some measuring instruments. So be like a ruler, a meter stick. If you're building or doing house repairs, you could use a, sorry, not building, you could use a measuring tape. There's all sorts of them. For thickness, there's something called a caliper. Okay, and you can Google that. It looks like a weird pair of tongs, and it can measure thickness, and then it's got a measurement on the side to let you know how thick that is. And you'll see them in gyms sometimes. People will measure their body fat with a caliper. So for SI rulers, and these are most rulers we have, and on a centimeter ruler, So this is these are all on a centimeter ruler. Okay, so the 4 to 5, this is 1 centimeter. Okay, and then if we look at this point right here, and I asked you what point is that on the ruler, this would read as what? It's halfway between the 4 and the 5, so this is 4.5 centimeters. And then over here, if I asked, what is that point right there? This would read as 4 points, so we have 5, 6, 7, 8, 9.9, and then we just kind of have to estimate the last digit to say that it's past 4.9, but it's not quite at 5, so we'll say 4.95 centimeters. And so this is an estimation. Okay? And usually at this level, estimations to the last digit are okay. Oh, so here's a caliper. A caliper is an instrument with a fixed scale and a moving scale. It can give an accurate measurement to the nearest tenth of a millimeter. Okay, so that's quite small and that's quite accurate, especially in everyday life. To read an SI caliper, you have to find the 0 on the moving scale, and then you read the number above it. Okay, so you find the next line on the fixed scale, and you read the value off the moving scale. Okay, so here you have the 2 scales. Okay, so this would be the fixed scale, and then underneath it you have a moving scale, and you'll notice the moving scale is a little bit smaller, and that's because it can move from side to side. Okay, so it needs to be smaller so that we can actually see that it's moving. And what we do is we read the first one here, and this reading is we would say it's very close to the 2. Okay, so the fixed scale, this would read as 2.0. Okay, and then we look down at the moving scale, and that's right about here, and then this one's more accurate, and so we go 1, 2, 3, so this one is 0.03 centimeters. Okay, and what happens is this reads as 20.3 millimeters, okay, because this is 2 centimeters, and 2 centimeters equals 20 millimeters, and you add the 2 together. So 20 plus 0.03 equals 20 point, oh, and this is 3 centimeters, so 0.03 centimeters equals 3 millimeters. And if you don't see how I'm getting these two numbers, this millimeters and millimeters, practice with your conversion factors, okay? So this would be 20.3 centimeters, okay? I'll change this to 0.3, or to, yeah, so 20 millimeters and 0.3 millimeters. And so you end up getting 20.3 millimeters. And so then the reading on the scale in centimeters is 2.03. And again, if you're not seeing how we get that, convert 20.3 millimeters into centimeters using your conversion factors. Okay, so we're going to go through some problems together, and then this will be the end of the first video. So, to estimate and measure using SI units. Estimate the width of this page using a personal referent, and then measure the distance using an SI ruler. Okay, so use a referent. So, let's use our fingernail. Okay, so like this, here's your fingernail. Okay, and there's your pretty nail, and there's your finger. So I'm going to estimate that my fingernail is about 1 centimeters across. Okay, so choose a referent. And we're estimating, so that's why we choose a referent. Okay, so I've chosen fingernail, and you can choose anything. You can choose your pencil or your eraser length or anything. And so my fingernail equals approximately 1 centimeter. I will do on your page, see how many you can fit across, okay? So just kind of eyeball it, move your finger, and so I can fit, and of course your fingernails will be different sizes, so I can fit about 18 fingernails. And this is about 18 centimeters. Okay? And then if you measure with a ruler, so get a ruler out and measure the paper. And see what you get in centimeters. Okay? And see how accurate they are, and on Thursday's class we'll talk about it. Okay? So see how accurate it is, and then think about if you'd want to use that kind of accuracy in your everyday life. So, example 2, we can convert between SI units for length. Okay, so this is more accurate. Okay, so we're told that the distance of the Earth from the Earth to the Moon is 440,300,000 centimeters between the Earth and the Moon. But centimeters is a weird unit to use for distance, right? What unit do we normally use for distance? Think about the distance between Surrey and Vancouver, or Abbotsford and Langley, or even Vancouver and LA. So we normally would use something like kilometers, okay? Because you see these on your signs. Kilometers makes it a little bit easier. So let's use our conversion factors. So we want kilometers. We have 38,440,300,000. Make sure you keep all your zeros. And what do we know? So, and this is in centimeters. So to get rid of centimeters, I should put centimeters on the bottom. In 1 meter, there are 100 centimeters. And then I want to get kilometers, so I should put meters on the bottom. And I have 1,000 meters. So I double check, my centimeters have crossed out, my millimeters have crossed out. I look at it and I think centimeters are small and kilometers are big, so my answer should be smaller than this number. It should be smaller. So let's see. So when I do the math, I do this 38 billion number divided by 100 and then divided by 1,000. I will get 384,403 kilometers. And that is a much neater number. Okay. Another conversion here, a worm measures 0.0019 meters. Now again, if it's that small of a number, meters probably isn't the best option for the unit. So what's a better choice? What's a smaller unit than meters or than meters? And you can try, look way back to the front page. So here's meters. What's a better choice to find the length of a worm? Okay, so centimeters or millimeters, I would think. So let's see. Let's choose millimeters. Okay, most worms are quite small. Of course, earthworms are a little bit bigger, but most are quite small. So let's start with want equals have times know. We want millimeters. We have 0.019. 0.019 meters. And what do we know? That in 1 meter, we put that on the bottom so we cross it off, we have 1,000 millimeters. Okay, and again, look at it. So meters are bigger than millimeters. Meters are bigger than millimeters, so I would think my answer would be bigger because I will have more millimeters than meters. And let's see what will happen. So when I multiply 0.0019 times 1,000, I end up with 1.9 millimeters. Okay, and that is bigger. 1.9 is bigger than 0.0019. Okay. And then the last problem we'll do is solve a problem using linear measurement. Kayla buys an oversized wooden barrel. She cuts it in half to make a planter. She wants to place a metal band around the planter 4 centimeters from the top to hold the planter together. Okay, so here's her barrel. Always draw situations out in word problems. And we'll cut it in half. Okay. And then here's her barrel cut in half. Okay. Forgive my drawing. And she wants to put a band here. And it'll be 4 centimeters from the top. Okay, so there's 4 centimeters between the band and the top of the planter. If the radius 4 centimeters from the top is 0.6 meters, what length of band will she need? Okay, so in this we'll have to look at the data pages, okay, and I will have this posted so you can print one off, but we'll talk about, I'll just talk about it right now. So we want to find the length of the band, and it's going to be going around the whole barrel, around the barrel, if we're looking down on the top of the barrel. Okay, so to find the length of the band, we have to find the circumference, and hopefully you remember that word. It's a circle word, the circumference of the planter. Okay, and the circumference would be the distance around. So if you have a bracelet on, the bracelet is going around the circumference of your wrist. Okay, so in this case, to find circumference, we use C equals 2 pi r. Okay, where pi is just on your calculator and r stands for radius. Okay, radius. So that's from the center point of the circle out to the end. So we have C will equal 2 pi and then r. What is r? So if the radius, and it tells us in the question, if the radius is 0.6 meters, so it tells us that, good, 0.6 meters, what length of band will she need? So if we do this in our calculator, make sure you use the pi button on your calculator. Okay, don't just enter 3.14. Actually use pi. We end up with 3.7699 meters. Okay, and we can round that up to 3.77 meters. And what did the question ask for? Do we want it in meters? No, we want it in centimeters. Okay, so let's convert. We want centimeters. Okay, we have 3.77 meters. And we know that in 1 meter, there are 100 centimeters. Okay, so if you do 3.77 times 100, we end up with 377 centimeters. And that is our answer. Okay, and then continuing on this, if the bottom band, so here we go, here's our barrel, and here's her top band. Again, drawing this out will always help you visualize what's going on. Sometimes with word problems, it can be hard to understand what they're asking. So drawing it out will usually help you get a head start. So here's my top band, and we know that this is 3.77 meters because we just calculated that up here. And if the bottom band is 1 meter shorter than the top band, what is the radius of the planter at the bottom band? So the bottom, the length or the circumference is 1 meter shorter. So the circumference of the bottom equals 3.77 minus 1. And we end up with 2.77 meters. And then we want, again, in the nearest centimeter, so we just have to convert this. So we have 2.77 meters. And we know that in 1 meter, there's 100 centimeters. And we end up with 277 centimeters. Okay, so here's your assignment for this section. Do questions in the textbook, and I will scan this in and post it as a document. So I know you don't have the textbook, but you will still be able to do the assignment. So on page 16 and 17, number 235, and then so 235 to 8, so 5, 6, 7, 8. Okay, and I will also post the answers up so you can check your answers. Feel free to watch the video more than once if you're not understanding. Okay, and then you can also email me anytime. My email address is on the course outline. All right, so check back because there'll be another video. We just want to get you all caught up. Okay, thanks.